Alright, hello everyone, this is Jeff Scott, IT instructor in the Application and Website Development program at Rankin Technical College, and what I've decided to do is, since the next test that we are taking, that's supposed to be on chapters 13, 14, 15, and 16, is basically on 12 and 14, I've decided to just do lectures on the PowerPoints or PowerPoint slides for chapters 13, 15, and 16. So that's what I'm doing now. So what I'm telling you is there should be absolutely nothing on your test that you will take next week on chapter 13, how to work with indexers, delegates, events, and operators, or chapter 15, how to work with interfaces and generics, or chapter 16, how to organize, document, and test your classes. Now, I think that what we go over in chapter 16 is important enough that we will do a project that will discuss that on Thursday. All right, so how to work with indexers, delegates, events, and operators. Here's our objectives. Develop and use classes that basically utilize all these. Describe the use of an indexer. Describe expression-bodied indexers. Explain why you should validate parameters and throw exceptions in your classes. Describe the use of delegates and events with and without anonymous methods and lambda expressions, and describe the use of operator overloading. Now, if I had to pick two things out of there that I thought were the most important, I would pick number 3. Explain why you should validate parameters and throw exceptions in your classes. And number 5, describe the use of operator overloading. So those are probably the two that I will spend the most time on. All right, so if you take a look in here, what do we have? All right. The code for a simple product list class, and it says part 1. So we've got a class here that's called product list. It has in here, you'll notice it looks a little different from the simple instance variables we've been creating before. We've got a list of products that's called products, a product list that's called products. Here is our constructor, okay? It is our NOAR constructor, and it's setting products equal to a new list of type product. All right, we've got a count method, which will show us how many items are currently in our product list. We've got an add method that allows us to add a new product, and you'll notice we've got one right here. It's an overloaded method, and if you've got to start to understand how this stuff works. So what this is really expecting is that when you call the add method, you will be providing a string for the code, a string for the description, and a decimal for the price. How has this changed from what we did earlier? What we did earlier is we broke this up, and instead of having a product list, we had these as instance variables. Now we're combining them, but remember, you can't really combine those into an array because we've got different types of variables here. So we're making a list so it can hold, it's a list that will hold all of our product codes, all of our product descriptions, and all of our product prices. All right? And then we create a new product based on what we just had passed in, and then we call the products.add right here. All right, so then we call the default constructor right here, products.add p. All right. So what else do we have in here? We've got a get product by index. So in other words, the idea is this is kind of a search or a lookup type of thing in here, that if I provide an index, so if there's 10 products, those being products 0 through 9, and I give you 3, it will show me the 4th product. There's a method in here to remove a product. All right. And then finally, there's a method in here that will, notice it says fill, and it's got get products, and that probably is going to fill like our list box or whatever, and the ability to save our products. So that's it. So they explain all that in here, and I'll leave that up here for a second, but hopefully at least I said it all correctly, and hopefully there's nothing new that's in there that I have not already mentioned to you. All right. And so here are basically the constructor. Okay. Now notice indexer provides access to the product at the specified index. Code provides access to the product of the specified code. I liken them to being lookups. So for instance, when you think of a lookup, now granted that many of you watching this are too young to remember phone books, but the old idea was that if you knew somebody's name and address, so let's say you knew a John Smith, and you knew John's address, but you looked in the phone book, there'd be a lot of John Smiths in there. But if you looked at, and it had the address and the phone number, and you could look up the address, you could figure out which one it was. So the address would basically have been your indexer in that case. All right. We've got a count property, again, to show you how many products are in the list, an add product to add the specified product to the list. And here, this add, as it says, is creating the product object and then adding it to the product list by calling that particular constructor. There's a remove, there's a fill, and there's a save. Now, when you look at this, here are some overloaded operators. Notice the plus sign. It says adds a product object to the list. That's not addition. When I say it's not addition, it's not like 3 plus 4. It's going back to my example that I gave you before about adding a name to a phone book. All right. Or as, another example, okay, maybe a little bit more pertinent or germane example, that if I go out here and I go out, just going out to my mail here, and I type in all right, my class was working on this a while ago, but this is the phone list at Rankin. There you can see mine. I don't think I picked my phone up in a year, to be honest with you. All right, because my mail all goes to voicemail, but the point is this. As people come into Rankin and as people leave Rankin, this list will be updated. Mr. Glenn has been here for quite a while, and he's the only one currently in the admissions office. Previously, we had him and we had Brandon Fan. Brandon has left the institution. All right, so there was an example where somebody was removed. All right, fairly recently. All right, because I've only known him for a while. We've had Robert Jafrida, and he's one of the electrical instructors. Real nice guy. He's the guy who's in the conference room in the morning when I'm in there in the afternoon. So he was fairly recently added to this list. All right, Mr. Parsons used to work at Rankin, so he was on this list. Then he left Rankin for a bit, and now he's back. So that's an example of somebody who was added to the list, then removed from the list, then added to the list again. All right, so hopefully at least that at least somewhat makes sense to everybody. All right? Just in the same way you can add somebody to a list, again, you can remove them. So these are overloaded operators. Don't look at this as being addition and subtraction. All right? All right, and when in the sense of adding and subtracting numbers, these are working with objects. So this is the ability to add a new object or remove a current object. All right. Notice there's a change handler, as it says. It can be used to register the method that's used to handle the changed event, and there's the changed event itself. Notice, raised when a product object is added to, updated, or removed from the list. So whenever there's changes made to the product list, that changed event will take place. All right. Now, I don't want to run through a lot of this code because it gets really confusing really fast. All right? So rather than using, as they showed here, index or code, here they're doing it, but they're using an actual number. All right? So that will return a product at that index. That will set a product at that index, etc. Here's a read-only indexer. How do we know it's read-only? There's no setter. All right, here's code that uses those. Again, I don't really want to run through this very much. It's very easy to get confused with this stuff. When you start to work with this stuff, again, notice they talk about using expression bodies. Remember, this is a shortcut. All right, for your getter and for your setter. Okay? All right. An indexer that checks the range and throws an exception. Well, it's pretty important that if you're doing a get, that means that you're trying to, you're getting passed in, you want to look up at that index. But if you give a negative one, or let's say that you've got 10 products, meaning they're products 0 through 9, and somebody gives you a 13 here, that's too big. So we're throwing an argument out of range exception. All right. And there's another example there with a code. Okay. So they've got 3 different kinds of exceptions that you can get. The good news is we've looked at these already. Now, not in the purview, so to speak, of using these with objects, but we have, when we were working with arrays and the like, we did argument out of range exceptions, we did argument null exceptions, we did argument exceptions, and it works the same way. When an argument is outside of the allowable range, when the argument is not given, or when the argument is given but it's in some rotten form. So when we looked at it in here you're looking at a string, and that should be fine for just about anything. But here, if you'd pass something non-numeric, you'd get an argument exception. All right? An if statement that validates data before setting a property. Always a good idea. All right, the next thing that's discussed in here is a delegate. And this is going, in some ways at least, almost from bad to worse as far as understanding or understandability. When you think about a delegate, what you should think about is somebody who's been given authority to do something by somebody. So in other words, if I knew I was going to be sick today and I delegated the authority of teaching my class, let's just say to Mr. Corrigan. All right, that would be an example of a delegate. All right. Now, I'm not going to run through this because, like I said, it gets too complex in my humble opinion. All right. So I'm just kind of blasting through this stuff fairly quickly here. All right. Let's talk a little bit about overloading. When you overload an operator, you're able to use it not so much for another purpose, but you're able to use it on other kinds of data. What you don't want to do is you don't want to, for example, here's the operators that you can overload, okay? So this is the positive operator, that's the negative operator, the not operator, the auto increment, the auto decrement, and the Boolean operators. You don't come in and do stuff like overload a plus so that it subtracts. But typically, you overload the way that we've already talked a little bit about. And that is, you have them do their operations, but rather than doing them on simple scalar variables, you have them do their operations on objects. So there you can overload both unary operators and binary operators. All right. So here's some examples. Equals object returns a Boolean value. So there's equals whether the current object refers to the same instance as the specified object. So if you want to go and see if 2 objects are of the same type. Here is if 2 objects basically, you can say they're equal to one another. No. Notice it says it compares 2 objects to determine if they refer to the same instance. So this equals does not say this. This says that one of these 2 objects is an alias for the other one, and they both point to the same object. The get hash code, again, it's fairly complex stuff. As it says, it returns an integer value used to identify objects in a hash table. All right, don't even want to say anything more about it than that. So here they've come in and they've overloaded the plus operator. Again, to allow you to come in, and it looks like in here we're probably adding an object to a list or something like that. When you do that, you can do it like this, or you can do it like this. The shortcut operator works just fine. All right. It's probably just about all I'm going to go through in here. Let's quickly look. So they do go through this delegate example in here. Like I said, I'm not going to spend any more time on it. You're not going to be tested on this. All right, there's nothing that you'll have to really worry about in this particular example. All right, so what I'm going to do is I'm going to stop here, and I'm going to come back afterwards, and I'm going to come back and talk about Chapter 15, which is on working with interfaces and generics. So I'll be back with that discussion in just a couple moments.